Hello everyone, this is SP Gubi online classes for Mathematics and Science for NCERT 10th Standard and CBSE 10th Standard. So in this physics session, we will be going with the light chapter, very important. So in the previous session of light, we had discussed regarding the lens formula and the sign conventions which are used in lenses which are related to numericals. So we will revise the things what we had done in the previous class. Next we will move on to the magnification of lenses. Very important concept, right? So according to the concept what we had learned in the previous class, so it was a very important class. I hope you have seen the videos, you have watched it again and again so that you get a grip on that. So based on that, every measurement what we do, it is done from the optic center of the lens. So it is done from the optic center, that is the center of the lens. So whether it is the object distance or the image distance, whatever measurement it is done from the optic center of the lens. Second point, if you are measuring something against the direction of the light rays, that is incident light rays, that measurement will be taken as negative because you are doing it against the direction of light rays. Keep this in your mind. So anything you are going to measure along or with the direction of the incident light rays, then it is taken as positive. So usually object distances will be taken as negative, and image distances, if they are real and inverted, they will be taken as that is negative, that is positive. So if the images are virtual, then they are taken as positive. So these are the things very important. Okay. So in the next rule, anything what we measure above the principal axis, that is taken as positive, and anything we measure which is below the principal axis, that is taken as that is negative. So usually the object height of the object or the size of the object is taken as positive because we keep the object always above the principal axis. And in case of a virtual image, as the virtual image is also formed above the principal axis, therefore the height or the size of the image is taken as positive. But if the image formed in the lens is a real and inverted image, then the height or size of the image will be taken as negative because it is measured below the principal axis. Okay. So along with that, we went with the lens formula, which is very important. So it is the relation between u, v and f. So minus 1 by u plus 1 by v is equal to 1 by f. That is the lens formula. So you have to remember this. So this was the things which we had covered in the previous class. So in today's session we will be going with still more important concept related to lenses, that is magnification of lenses. Right. So here magnification of lenses plays a very important role because while doing numericals we need the help of magnification to compare the size of the image with the size of the object. So we need the magnification concept, right? So here we have seen in the ray diagrams connected to concave lenses and also as with the convex lenses, images are formed that is on the other side of the lens. So those images, when we see in the ray diagram, we get confirmed that the size of the images goes on altering, that is it is going to change. So when you bring the particular object nearer and nearer to the lenses, the size of the image goes on increasing. So when you take the object away from the lens, the size of the image goes on decreasing. So somewhere at a point, the size of the object will be equal to the size of the size of the image will be equal to the size of the object. So all these things we have seen. So also we have seen virtual images also. So here most important definition for magnification of lenses, just like similar to the magnification of mirrors, this is the magnification of lenses, very simple. So magnification of a lens is defined as the ratio between the height or size of the image formed to the size or height of the object kept in front of the lens. So this is called magnification of lens. So the ratio, the name given to that ratio is called the magnification of lens, right? So once again I will repeat. So what is our defined magnification of a lens? The magnification of a lens is defined as the ratio between the size or height of the image to the size or height of the object which is kept in front of the lens. So magnification here also, in case of lenses, it is represented by small letter m. Okay, I will go with the numerical thing. So magnification m is equal to size or height of image. Size or height of image by size or height of object. So here we see that m is equal to size or height of the image. Usually it is represented by h dash. By size or height of the object is represented by h. So m is equal to h dash by h. So this is the relation you have to remember, and whenever required you should recall this. So these things are required while solving problems on lenses, right? So we will go with the magnification that is related to the lenses, that is relation between u1v and magnification. We will go with a very simple derivation here. So the derivation is based on the relationship between m, that is magnification, object distance, and image distance, that is m, u and v. Let us see the derivation, how it goes, right? So usually we have seen a lens. Let us take the help of a convex lens. This is the optic center. So this is C1, C2. Write this. This is the optic center. Okay. So this is where I am going to keep the object. I will call it as A, B. So this is the convex lens. So this is the object AB, which is kept in front of it. Right. So now let us take a light ray starting from A, that is from point A. Let us take a light ray which is traveling parallel to the principal axis. So the light ray, usually what we did in the previous ray diagrams. So one of the light ray should be taken from point A, and that should be taken parallel to the principal axis. So let it get into the lens, get refracted, and let it pass it through a point. So this point usually will be the principal focus, right? That is F2. Okay, let us pass another light ray starting from point A. Let it pass through the optic center of the lens. That is, I will make it to pass through the optic center of the lens. So this light ray and this light ray, they are going to meet at this point. Okay, I will extend the line, principal axis. So we can see here the image is formed at this point. So this is A dash and this is B dash. Now here OB is the object distance. So as the light rays are moving in this direction, okay, I write this. As the light rays are moving in this direction, I am measuring the distance of the object from the optic center of the lens, that is in the direction opposite to that of the incident light rays. Therefore, it should be taken as negative. This is U and this is minus U. Now, this is the distance of the image formed. So here, this measurement from the optic center to the image formed on the principal axis, I am measuring this distance along the direction of the incident light rays. So therefore, this is V actually, that is O, B dash is V actually. So that is positive because you are measuring from the optic center to the image along the direction of the incident light rays. So therefore, it should be taken as positive. Okay. So here, usually we take this object height or height of the object or the size of the object as h. So as h is above the principal axis, as this measurement BA, what I am taking here, is done above the principal axis, therefore it is h and that is plus h. So when you come to the image, that is A dash, B dash, I am measuring this distance or height of the image below the principal axis, therefore it should be taken as minus h. So this is according to the sign convections what we had discussed in the previous class, right? So with these things we can get into the derivation here. So I want to show you a triangle. So let us select two triangles here. So one is triangle ABO. Let's take this triangle here. Let us take this triangle. This is for your knowledge. This is no way connected to the examination, but for your knowledge I am doing this. So let us take another triangle. This is the triangle we have to take. Okay. So two triangles I have selected. One is a triangle ABO, another triangle is A dash B dash O. So this is another triangle. So if we see those two triangles, we can see here the triangle that is ABO and triangle A dash B dash O. We can see that angle AOB is equal to angle A dash OB dash. Angle AOB is equal to angle A dash B dash or A dash OB dash. So here we can see that this angle of this triangle is equal to this, that is in this triangle we have this angle equal to that. So these two angles are vertically opposite angles. So we can take it when two straight lines intersect at a point, then we say that the vertically opposite angles are formed and they will be equal. Okay. So as this object is standing perpendicular to the principal axis and this object, that is image, is also formed perpendicular to the principal axis, let us take this as 90 degrees. Angle ABO is equal to angle that is A dash B dash O, that is 90 degrees. A dash B dash O, so that is 90 degrees, right? So in these two triangles, two corresponding angles are equal, then the third angle will be compulsory equal. So therefore, according to the angle criterion, right, which you are going to study this in the similar triangles chapter, therefore triangle ABO is similar to triangle A dash B dash O. So therefore, if two triangles are similar, we know that their corresponding sides will be proportional. Your mathematics teacher, maybe he has discussed these things with you. Okay. So this is triangle ABO similar to triangle A dash B dash O dash. So therefore, this triangle and this triangle are exactly similar. They have the same shape but different sizes. Right. So therefore, their corresponding sides will be compulsory proportional. So we write the proportionality. So here we can write this O, that is okay, A dash B dash by AB, A dash B dash by AB, right, will be equal to OB dash by OB. OB dash by OB is equal to OA by OA dash, which is not required for us, so I am not taking that ratio. Okay. Now, we'll continue the derivation. So here, what is A dash B dash? So here we can see that A dash B dash is nothing but minus H, that is the size of the image. So by sign conventions, right? So here A dash B dash is minus H, right? And AB is the height of the object, so therefore AB is plus H, okay, and then OB dash, that is this one, OB dash, that is plus V, that is OB dash is equal to plus V, and OB, this one, this is minus U, so OB is minus U, right? So we'll apply all the four sign conventions to the ratio there. So we get minus H by AB, that is H, is equal to OB dash, that is V by OB, that is minus U. So this can be written as minus H by H is equal to minus v by u. So minus and minus cancels. So h dash, okay, this is h dash minus h dash, that is a dash b dash. Okay, so my h dash by h is equal to v by u. But just now we have seen that m is equal to, in that relationship, m is equal to h dash by h. So therefore h dash by h is equal to v by u, but h dash by h is equal to the magnification. So therefore m is equal to h dash by h is equal to v by u. So therefore we can clarify this. So therefore m is equal to v by u. So magnification is, that is m is equal to, that is image distance by, this is object distance, image distance by object distance. So this is the very important derivation you have to remember. So when do we say that magnification is positive? So here, in case of convex lenses, only one case is said to be where we are going to get the virtual images. So in that case, where you are going to get virtual images, when you place the object in front of the lens, and in any case you get the image, that is the image as a virtual image, then we say that the magnification is positive. So if in case of a convex lens, usually we get all the images as real and inverted. So if the image is real and inverted, then we say that magnification is negative. Very simple, you have to remember this. So in case of lenses, when is magnification positive, and in case of lenses, when is magnification negative? So here, when you place the object in front of the lens and the image what you have got is a virtual and erect image, then we say that the magnification of that lens is positive. So now take a lens, keep an object in front of it, and due to that, if you are getting an image which is real and inverted, then we say that the magnification is negative. You have to remember this, because this is a very important that is concept which is required for solving numericals on lenses, right? So I hope you enjoyed the entire concept. So this was regarding lenses. So in the next class, I will be going with the power of the lens, which is still more an important concept, and after that we will be going with numericals, right? So please watch the video again and again so that you can get a grip on this. So very soon you are going to write a test on the light chapter. So it will be a very challenging one, because it has a lot of concepts inside it, all numericals, ray diagrams, everything you have inside it. So therefore please keep updated. Notes is 100% updated. Until now what the concept is covered, notes is with you. Read the entire notes, read the textbook. First read the textbook, then go with the classwork. So don't miss up the things. Get ready for the test, a light chapter test on coming Sunday, right? I wish you all the best. Get ready for that. So some worksheets I am going to send you through WhatsApp. So regarding the test on polynomials, it was a fantastic performance by you. So many of you, most of you have done very well in that. So one problem particularly, find the value of alpha square plus beta square, that particular problem, many of you have done a silly mistake in that. So I will WhatsApp the right method of solving this, and also I have sent you all the answers of the particular question paper what was given on Sunday of polynomials. So go through that, check out your answers. If you have any doubts, please WhatsApp. See that you are updated, you are studying. We don't know what the things are going to happen in future. Maybe these classes will help you a lot to cope up with your syllabus. So until then, take the study seriously, see that you are on the right track. Stay home, stay safe, keep learning. Thank you.